Hi, I'm Alex Souza. I'm Celera's founder and current CEO. The way I like to say this is that the control of fire is humankind's oldest technical challenge. So being able to control fire is what put humankind in a path of development. From the moment that we were able to cook food, make our tools, we truly started to become a civilization, started to achieve breakthroughs in terms of technology. And what is interesting is that 6 million years after the control of fire, controlling heat, one of fire's subproducts, is still the main technical challenge for today's emerging technologies. That's the arena where Celera is active. Celera researches, develops, and manufactures advanced materials for thermal control and thermal management in electric and electronic appliances. 4 years ago, it was the beginning of 2019, when our American distributor company called CDI approached Celera with a unique opportunity. They said that a new Madison Square Garden, the famous New York entertainment venue, was being built in the middle of Las Vegas. And not only that, but this new entertainment venue was going to be the largest ever LED screen in the world. And as Celera specializes in thermal management solutions, there was a unique chance for us to be part of this project, guaranteeing the reliability and performance of those LED modules. Internally, this opportunity triggered a myriad of different internal evaluations and processes at Celera, because it was necessary not only to develop materials that did not exist then, but also couple this new offering in terms of advanced materials to a new logistics operation, to a new support operations, and also to a new assembly support. Since we're talking of over 5 million parts, something that Celera had never manufactured before. So the way we see this is that it was really a holistic challenge that would need to involve all sections, all processes at Celera, and not only material development. Pretty much the starting point for us was to take the customer's technical requirements, what they needed the LED modules to achieve in terms of bright, color intensity, and other parameters, and try to match that to the kind of materials that Celera had already in our portfolio. As a result of this analysis, what we found is that we did have a pretty good beginning, but the materials that we had would need to be finely tuned, adjusted, and somehow improved to meet the very challenging requirements for this project. And that's when our engineers really got to work and came with amazing results. In a matter of not more than 3 months, we were able to develop 2 new materials, beginning with substrates that Celera already had in our portfolio, and not only reach, but as a matter of fact, surpass most of the thermal, mechanical, and electrical requirements that the customer had for this project. So when CDI came to us, and of course they were afraid if we would be able to match such a gigantic project, we said, we're ready, because as a matter of fact, we knew that Celera was able to develop the kind of material that the customer needed. Of course, it was a challenge in terms of the logistics involved, in terms of the scale of the project, but the technical expertise, the foundations, the building blocks that allowed us to develop exactly the type of material that is going to guarantee that the 2.4 million LED modules keep shining and bright for years to come was already present at Celera. So we were basically talking about 2 different components that go inside each one of those LED modules. So interesting enough, any kind of electric and electronic application will probably produce more heat than any other product. So take a LED light, for example, you're going to have more heat out of that device than light. So getting this heat away as fast as possible and as reliable as possible is the number one challenge that any application is going to face. So this was the challenge that we had in front of us. Develop materials that will be not only fast in terms of thermal transportation, but also reliable. They needed to, on one hand, withstand the very hostile environmental conditions of the desert in Las Vegas, where you have extreme heat, extreme temperatures, sand, and on the other hand, also materials that would last for many years to come. So Celera was able to develop two different kinds of materials. So the first need was to develop a thin filmic material to be applied onto the ring that goes on top of the LED module. So this ring sits right on top of the LED's enclosure and has the function to attach the lens that protects the interior of the LED module. So there we needed a material that will be very flexible, highly thermal conductivity, and not only that, that needed to be applied automatically, because at the end of the day, they're going to produce 2.4 million of those rings. So Celera had to came up not only with a material that would meet the technical requirements, but also with an assembly process that would allow the customer to gain high throughput rates, so high productivity and an automatic assembly process. For the second material, and this is really the most important material in this case, and the material that really creates the conditions for those LEDs to shine and to be bright for years to come, was the thermal interface. So thermal interfaces are usually placed between a heat generating surface and a heat dissipating surface, in this case an aluminum heat sink. So whenever you bring two contact surfaces together, you get a lot of air trapped inside, and air acts as an element that prohibits, that makes it hard for heat to be transported from the LED to the tips of the heat sinks. That's where we needed to use a material that would conform to the roughness of both surfaces, get the air away, and thus build a bridge, a thermal bridge that would enable heat to cross from inside the LED to the tips of the heat sink in a very natural and fast way. In this case, we came up to our cool pad line. So cool pads are silicon membranes activated by different types of thermal fillers, ceramic and graphite, that are extremely soft, extremely compliable, and that we thought had the chance to meet this challenge. That's when our engineers started to fine-tune this material in order to decrease the hardness. It was already a very soft material, but we needed it to be even softer. So how can we do that? Not only that, you don't want the material that is soft, but that is not resistant enough. So this was the main challenge. We needed something that will be very compressible, very soft, but at the same time, very resistant. So with CoolPad, you get the best of both worlds, right? So you have a material that has extremely low thermal resistance, exactly because it conforms to the roughness of the contact surfaces, but also exhibits extremely high thermal conductivity. In this case, 5 watt per meter Kelvin, which is extremely high. So with CoolPad, you're really able to tap both worlds. Extremely low thermal resistance, extremely high thermal conductivity. Another challenge that we had to overcome was related to logistics. Celera is in Brazil, at least until 2020. It was headquartered only in Brazil, and the customer that was going to assemble our process was up in Canada. So how can we shorter these distances? How can we be punctual and make sure that every consignment is delivered on time, all the time. The solution was not easy, but very effective. So how can we deal with this? How can we shorten the distances? How can we be closer to the customer? So why not have a warehouse in the USA? And that's exactly what we did. So for this project, Celera set up a warehouse in the south of the US where most of the material was stocked and able to be delivered within a maximum of 2 days after a customer's PO. Project basically gave us the chance to increase the pace of plans that we already had. Celera already had in its strategic plan the idea of setting up a facility in the US. So working with Seiko, working with MSG Sphere gave us the opportunity to anticipate these plans and have our daughter company in the US. So with this company, which is still active, we are now able to supply to our customers in the US in a much faster way and thus leverage our operation in the North American project. Having a warehouse in the US has enabled Celera Thermal to have extremely high service rates to customers in North America, in the US, in Canada, and in Mexico, with very short delivery times and a local support. This was no easy task. So in a regular production, you have around 1,000, 2,000 thermal interface parts being assembled every day. So when you scale that up to 5 million, you do have quite a great challenge in front of you. So again, when you're talking about assembly 5 million parts, you cannot use off-the-shelf solutions. So once again, Celera had to think outside the box and come up with very new technologies and new ways to incorporate those parts onto the LED modules. So once again, our engineers had to go back to the design board to come up with a machine that will be compact, fast, reliable, and that could be operated in Canada. The problem is, the moment that the machines arrived in Canada, the world shut down. That's when COVID came. So we had no chance to go to Canada and train the customer in how to operate those machines. So that's where we really had to excel. So a lot of video calls, a lot of manuals, a lot of effort from both our team and our customers' team in order to make sure that those machines will be rightly commissioned and operated. What is also unique about this project is that each one of the 2.4 million LED modules of the Sphere are not only one of its features, but they are the true soul of the Sphere. When you talk about sports arena, you may have a huge LED screen, but if it turns off, the match keeps going. That's not the same with the Sphere. The moment any of those LED modules have a problem, the show is over. So that gives you a rough idea of the kind of technical challenge and requirement that Celera had to overcome to make sure that the dreams, the magic behind this amazing venture would need to put up. Part of this project has been really surreal. Not that we're not confident on our skills and expertise, but when you see this Sphere glooming in Las Vegas, you really see what the human mind is capable of doing. Celera is the only Brazilian company to take part in this project. And as I always say, it is possible to do it right. It is possible to do it good in Brazil. We do have the technical expertise. We do have the engineering capabilities to be able to supply solutions that are cutting edge and world level, world class. In one of the videos that were recorded at the Sphere, the legendary Bono Vox, the U2 lead singer, said that the Sphere is the most important entertainment venture since the Colosseum. And I think he's right. So most of the arenas that are used for shows right now were built for sports, not for art. So the Sphere was really built for art, for beauty, for music. And this is something that we really take to our heart. So Celera's mission is very linked to people's lives. So our mission is to improve people's lives through our passion for technique. So the Sphere was really a once-in-a-lifetime opportunity to match those technical skills, to match the passion, the engineering passion, the passion for technique, to something that was really going to amaze people, to make people think about the arts and the beauty. So I would say that the main legacy that the Sphere has brought us is a strengthened sense that Celera does have the necessary technical skills to meet the requirements of any project, be it small, be it big, may it be locally or international. We are able to fulfill any kind of technical requirement. I believe that what set us apart in this process was really the way we approached this offer. From the very beginning, we understood that we were not talking only about the best thermal interface. So we had to be able, of course, to supply very technically advanced materials, but not only that, the logistics, the assembly process, the short delivery times, everything will be taken into consideration. And I believe that Celera was able to be nominated for this project because truly we looked at this project not from a monofocal view, not from a single perspective, but understanding that in order to be really successful, we needed to tap into every single layer of this very complex and wide value chain. So very early on in this process, we understood that being price competitive was something important. We do take our price competitiveness very seriously, but this project was not going to be decided only based on the best or the lowest process. That's why we had to bring to the table not only a commercially very competitive offer, but also the best possible solution in terms of product, the best possible solution in terms of logistics, and the best possible solution in terms of the assembly process. So with Celera, what we think of innovation is this very structured, intentional, and rational way of not only bringing up the best possible technologies, but only the technologies that will truly create value to the end customer. Because you see, nice technologies are all around us, and many come, many go, but only the technologies that are really able to fulfill and to allow customers to perform their tasks better, faster, in a more economical way, truly are able to create values and to establish themselves as successful products.